Hi guys, good morning. So in the last session, we have seen about DTP and VTP protocol. And today, before starting STP, we have one more topic, which is about inter-VLAN route. Okay. So what is this inter-VLAN routing concept? What is this concept? Inter-VLAN routing provides communication between two different VLANs. Okay. Let's say I have two switches. Switch one, switch two. Okay. Then I have a host here. I have a host here. This is switch one. Switch. This is PC1. This is PC. F0 by 0, or let's say 0 by 2, and this one is E0 by F0 by 1. This is F0 by 2. This is F0 by 1. So this side belongs to VLAN 10. This side VLAN 20. This host has an IP address 10.1.1.1. This one has an IP address 10.1.1.2. And you need to provide communication. How you will provide? Hmm? Okay, one possible way is native VLAN. Any other way? Hmm? Using router and layer 3 switch. Any other way? Yes or no? No. What if I make these ports as an access port? Because your tagging takes place where? On the trunk port only. So let's try something. What I'll do is I'll set this port on VLAN 10, this port on VLAN 20, and then we'll try whether or not they are having the communication. Agree? This is the case number one. Okay. Where we are trying what? Using access port. So let's try this thing. So what do you think? Will I have a communication? If I set this port to VLAN 10 and this port to VLAN 20, I'll have a communication or not?
Yeah, it will have a communication.
Okay, you think it will have a communication? Anybody
The
else?
last time you had explained on the same thing, right? And you recommended not to use this.
That was a native VLAN. That was a native VLAN concept.
Okay.
Right now, these ports are working as an access port only. Okay. What do you think? Will have a communication or not? No? Anybody else? Anybody who thinks we'll have a communication? So I'll take two switches. Okay, and I'll take two PCs. So for PC, I'll just use VPC only. Switch 1 connected to PC1. Switch 2 connected to PC. And then switch 1 connected to switch. And this is our scenario. Start all the nodes. Switch 1. So PC1 will have an IP address 10.111/24. This will have an IP address 10.112. Switch 1, switch 2, PC1, and PC2. So PC1, I'll set an IP address. I'll say IP, and IP is 10.111, mask is, okay. I check show IP, so I can see 10.111/20. And here, same thing, 10.112. Have a communication, right? Right now, we don't have any sort of VLANs. Okay, so that means everything is default. All the ports are access ports and belonging to the same VLAN, which is VLAN 1. So I should have a communication. So if I try to ping 10.112, I should be able to ping, and you can see I am able to. Okay. Now what? I'll add this one into the VLAN 10. Okay. PC1, I'll add it to the VLAN 1. I mean VLAN 10. And this will be part of VLAN 10. This is VLAN 10. And this one will be VLAN 20. So let's configure it. Switch 1 interfaces. Interface gig 0/0. And how do I add it in the VLAN? Switch port access VLAN 10. Okay. So now I can check do show VLAN brief, and I can see Z 0/0 is a part of VLAN. Correct. Same thing we'll do for switch 2. We will add Z 0/0 in the VLAN 20. Interface gig 0/0. Switch port access VLAN 20. Now this port is in VLAN 10. This port is in VLAN 20. Will they have communication? No. So let's try. First verify here. Do show VLAN. VLAN is added. Let's try the communication. So now I don't have a communication. Correct? Okay. It says what? Host is not reaching. Okay. Now what I'm going to do is I'm going to add this port in the VLAN 10 and this port in the VLAN 20. Using access port, we are trying. This one I'll add it in the VLAN 10. And this port in the VLAN 20. So logically, what will happen? Interface gig 0/1 with port access VLAN 10, and this side interface gig 0/1 with port access VLAN. Yeah. Done. Okay. Now this is in the VLAN 10, this is in the VLAN 20. Correct? Both are working as access port. We can check do show VLAN brief. Okay, so here Z 0/0 and 1 is in 10. And this side, if I check, 0 by 0 and 0 by 1 in the VLAN. Okay. Now, also I'll start a packet capture here so that you can see that .1 queue header is there or not. On access port, .1 queue header is there or okay. So we'll filter for ICMP. Okay, other traffic I don't need here. Now, I'll go to the PC1 and try. You see, I have a reply. I have the communication. Now, why I'm having this communication? Because if you take a look, the traffic is coming from 10.1.1.1 to 10.1.1.2. Does it have any sort of .1 queue header? No. Why? Because this is an access port and your tagging takes place on trunk ports. So this is the first way you can have communication between two different VLANs. Okay, but this is just a trick. And for this trick, there is a condition also that they have to be in the same network only. If you keep them in a different network, they will require a gateway. They'll require a gateway. Clear? Understood? This is scenario one using access port. Now let's say you don't want to use access port. This time we don't want to use access port. This is not inter-VLAN routing, okay? This is not inter-VLAN routing. Is to using native VLAN. Okay. So for native VLAN, these interfaces they have to be trunk. This interface has to be trunk. This interface also has to be trunk. Okay. So for this type of communication here, we will configure the native VLAN as 10, right? And here we will configure the native VLAN 10. Okay. This side native VLAN 10, this side native VLAN 10. Let's try this scenario. Now in this case, what will happen? The frame will belong to a native VLAN. So those frames will not be tagged. Clear? Okay. So let's take a look. So what I'm going to do on the switch 1 and switch 2, I'll change these ports to trunk ports. Okay. Z0 by 1 to trunk port. So interface Z0 by 1, switch port mode, trunk. So we have to give the encapsulation mode here. Switch port, trunk, encapsulation, dot 1 2. Okay, and then I'll say switch port mode, trunk. Clear? Same thing here. Interface Z0 by 1, switch port, trunk, encapsulation, dot 1 Q, and switch port mode, trunk. Clear? Okay. Now these interfaces are trunk interfaces. So if I take a look, do show interface Z0 by 1 switch port. So you can see that access mode VLAN is set to 20. No problem. But my native VLAN is what right now? Right? My native VLAN is what by default? VLAN 1. So now if the traffic will go for VLAN 10 or VLAN 20, there will be a .1 queue tag. Okay. So let's capture the packets. Again, I'll capture ICMP. And let's try to ping. So definitely, first of all, I'll not be able to ping here. I'll not have the connectivity. Why? Because of tagging. Yes or no? Because of tagging. So this PC is trying to send the packet. The packet is using what? A .1 queue tag and just a minute. To show VLAN. Okay. So 0 by 0 belongs to VLAN 10 and to VLAN 3. This is 0 by 0 belonging to VLAN. Okay, wrong interface I have kept. Z0 by, no, correct, correct. Z0 by 1 is the trunk. Okay. So this is okay. Then check to show interface trunk. So our Z0 by 1 is the trunk interface. Okay. And you see what are the VLANs allowed? All the VLANs. Same thing here. To show VLAN brief. Oh, sorry. Do show interface trunk. So here also all the VLANs are allowed. Okay. All right. Now debug IP packet. Okay, so what is going on switch 1? We want to see. Now again, I'll try to ping 10.1.1.2. Says not reachable. Why? Try to capture on the Z0 by 0 interface here. It is trying to send a ARP. It's trying to send a ARP. So then we can see the ARP also. That means in this capture, we can filter for ARP. And that ARP will also have a .1 queue. You can see, right? It is having a .1 queue, and in the .1 queue, the VLAN ID is what? 10. And here on this switch, okay, do debug IP packet detail. Now take a look. Nothing. Okay. Then we will debug ARP only. Debug. Don't we have an option for ARP? Yes. Table static interface. Okay. So here in the debug, we are not able to see it. But here you can take a look, right? That the switch 2 is getting ARP messages. Okay. The ARP messages are coming to the switch, but the switch is not responding. Why? Because switch is not able to forward. There is no VLAN 10 on the switch. The traffic is not relevant to the switch. Clear? So what we are going to do here? As of now, we see that here are what this .1q tag, and we can remove it by changing the native VLAN. Okay. So let's go and change the native VLAN. On the switch one, I'll put the native VLAN as 10. Okay. And here the native VLAN as 20. Interface Z0/1. Switch port trunk native VLAN 10. And here interface Z0/1 switch port trunk native VLAN 20. So what my STP did here, the STP blocked the port because of native VLAN mismatch. So what I'll do, I'll say spanning tree port fast trunk. Okay. Wait a minute. It says consistency restored. That means port is up. No need to disable STP also. Do show interface status. This is trunk and connected. And here also do show interface status. Here also it is connected. So that means now we should have the connectivity. No, then we have to do it. Do show spanning tree. Here it says it is in the forwarding condition. Do show spanning tree. Here also all the ports are in the forwarding condition. Okay. VLAN 20 is in the blocking. And here VLAN 10 is the blocking. So we have to disable STP on this port. I'll say spanning tree interface Z0/1 spanning tree port fast trunk. Okay. Z0/1 spanning tree port fast trunk. Now let's verify whether the port is up or not. Do show spanning tree. Still it is in the blocking condition. To show spanning tree. Well, STP is blocking.
I think you have to focus only on VLAN.
No, not about that. Let's try. Okay, we can do one thing. No shut down and no shutdown. Receive BPD with inconsistent. Here we can blocking. That should not happen. To show spanning tree. Designated port and blocking. Okay.
Sir, both needs to shut down. Don't shut.
No, that is not the case. We can stop the BPD. I can apply BPD filter also. Not a problem. So they won't send a BPD. Let's try no shut once, then I'll apply the BPD filter. It's blocking. So I'll just apply the BPD filter. I'll shut down the ports. And now I'll apply the BPD filter. Spanning tree. BPDU filter enable. This side also the same thing. BPDU filter will do what? It will not send out the BPDUs. Okay. Now let's try. No shutdown. No shutdown. Now the port should not go down. Native VLAN mismatch, that is not an issue for us. Okay. And now we are going to have the communication. Clear? So, like I said, these are just some tricks to have communication. Okay. Here, you just make it them as an access port. They will have the communication. And in this case, you will change the native VLAN, but that will cause what? Your STP to block the interfaces. Okay, so what you can do here, you can enable BPDU filter. Both sides, you can enable BPDU filter that will prevent your STP from blocking the link. Clear? These are the tricks, but these are not inter-VLAN routing. Okay. So then what is inter-VLAN routing? Like,
Sir, in case of different network,
in case of different network, we use inter-VLAN routing, right? These are the tricks. We can have communication within the same network.
okay, fine.
Okay. Now we will see in case when you have a different network. So inter-VLAN routing, you can say that it's a way of providing communication or routing traffic between different VLAN. Okay. This is a way of providing communication between different VLANs or routing traffic between different VLANs. Okay. Now, if we talk about inter-VLAN routing, we have three ways. Number one is router with separate interfaces. Number two, we have router on a stick. And number three is using layer 3 switch. Okay. These are the ways. Now, one by one, we are going to see this thing. I believe all of these methods you have already seen in your NA. Yes or no? Seen or not? Seen? So you will tell me how to do it. Right? Okay. So first one, router with separate interfaces. Router with separate interfaces. Now, in this case, what will happen? Let's say you have two VLANs. This is switch. PC1. And PC2. This is, let's say, for example, F0/1 interface. And this side also F0/1 interface. Okay. And this side belongs to VLAN 10. And this side belongs to VLAN 20. Okay, sorry. Yeah. This will be 2. Okay. So this side we have VLAN 10. This side we have VLAN 20. And the IP address on host 1, let's say 10.1.1.1. And this one we have 10.2.2. CIDR will be 24. Okay. Now they need to communicate with each other. Okay. In general, what is the best practice? That each VLAN uses one subnet. Each VLAN uses one subnet. So PC1 wants to communicate with PC2. If I try, will they communicate? No. Why? Different VLAN. Okay. What if they are in the same VLAN? Can they communicate? No. Why? Different network. So if you want communication between different network here, what do you need? Default gateway, right? And generally, what do we use as a default gateway?
Router.
Router.
Router circuit.
That means to provide communication between different networks, we need what? A router. So let's use a router here. I'll use a router, which is going to work as our gateway. Now I need one IP address from this subnet and another IP address from this subnet, right? So what I'll do, I'll connect one cable on this side and another cable on this side. For each VLAN, I have used separate interfaces. Okay. So you can say like this side, I have an interface Z0 by 0. This is Z0 by 1. Okay. So I'll keep one IP address here. Let's say gateway IP address 10.1.1.10. And this side, I have an IP address 10.2.2. Okay. But by default, what will happen? These interfaces of the switch. Okay. These interfaces, which is, let's say, F0 by 3. And this one is as F0 by 4. So by default, they will be part of VLAN. One, they will work as an access port, and they'll be member of VLAN 1. So we'll change the VLAN. I need communication of this interface with the PC1 and communication of Z0 by 1 with the PC2. Correct? So we need that, okay, these interfaces be in the same VLAN. Okay. So simply what we're going to do is this F0 by 3, I'll add it in the VLAN 10. And F0 by 4, I'll add it in the VLAN 10. Now VLAN 10 will communicate, VLAN 20 will communicate. So PC1 can communicate with the gateway, PC2 can communicate with the gateway, right? And router will be responsible for providing communication between these two networks. And since they are working as an access port only, there will be no tagging. There will be no tagging at all. This is clear. So configuration wise, what will be the configuration? Let's say if I talk about router configuration, first of all. In this case, so you'll say enable configuration terminal and all. On router, you do not require any special configuration, right? You will simply say interface Z0 by 0, IP address 255.255.255.0. Okay. Then you will say no shutdown. And similar comments Z0 by 1. This will be 2.2.10. This is your router's configuration. That's it. Clear? Then what about the switch configuration? If we talk about switch configuration, so switch configuration will be, you will just create the VLANs. That's it. Okay, you will say interface. Simply range we can use range F0 by 1 and F0 by 3. And you will say switch port access VLAN 10 and interface range F0 by 2 and F0 by 4. You will say with port access VLAN 12. This is your all the configuration. And your PC1 will start communicating with PC2. Okay. PC1 will use the gateway IP as 10.1.1.10. This will be the gateway. In case of PC1. And in case of PC2, the gateway IP will be 2.2.10. This is your router with separate interfaces. That means for each VLAN, you use a dedicated interface of a router. Clear? Clear? Okay. Note it. Online people, any doubt?
No, sir.
No, sir. Okay. Now the second method, which is about router on a stick. Okay. Router on a stick. Now, why do we have this method? Hmm? Insufficient ports in switch. So you can see here I used two VLANs, right? And I had to use two interfaces of the router. And generally routers come up with like 2 ports and 4 ports only. But what if I have 100 VLANs? Right? What if I have 100 VLANs? So now this is not scalable. I cannot go and use 10 routers there, right? Or more routers. Correct? So rather than using individual interface for each VLAN, separate interface for each VLAN, we need to use only one single interface. We need to use only one single interface. Okay. Now, let's consider the scenario again. We have a switch. Then we have two PCs here. These are connected. This is switch. Do I need to show it practically? Router with separate interfaces. Yes or no? Need to show. Okay.
And this side we will add VLAN 20. Okay. So this is VLAN 10. This is VLAN 20. Then I'll add a router. Which is our gateway. So two interfaces, Z0 by 0 will be there. Okay. Which will be for VLAN 10. And Z0 by 1 will be there, which will be for VLAN 20. Okay. Switch interface Z0 by 2 will be added to VLAN 10. And switch interface Z0 by 3 will be added to VLAN 20. Then 10.1.1.1 will be added to the Z0 by 0 interface of router. And 2.2 will be added to Z0 by 1 interface. Take access of gateway. Switch PC1 and PC. Okay. Let's configure PC1. So this time for PC1, the gateway IP will be 10.1.1.1. For PC2, gateway IP will be 10.2.2.1. Okay. So PC1, if I check show IP, I'll say IP 10.1.1.10. Gateway is 10.1.1.1. Okay. Show IP. IP address, mask, and gateway set. Now this is PC2. So IP will be 10.2.2.10. Mask will be 255.255.255.0. Gateway will be 10.2.2.1. Okay. Done. Now let's go and configure the gateway. No. And on the switch one, Z0 by 0 will be VLAN 10, Z0 by 1 will be VLAN 20. interface gig 0/0, switch port access VLAN, then interface gig 0/1, switch port access VLAN 20. Correct? And let's configure the gateway. Interface gig 0/0 will have the IP address. Gig 0/1. And no shutdown. Now, if I try to ping from PC1 to gateway, will I be able to ping? Yes or no? No, why? In switch? Exactly. Okay, we have added the interface Z0/0 in the VLAN 10, Z0/1 in the VLAN 20. But we didn't add these interfaces in the VLANs. So right now, if I say ping 10.1.1.1, I'll not have communication. Why? Because this interface is not in the correct VLAN. This is part of VLAN 1 right now. And that is the reason that this VLAN 10 will not communicate with VLAN 1. So let's go on the switch and let's add it. So I'll say interface Z0/2, and this will be part of VLAN 10, and Z0/3 will be part of VLAN 20. So do I have communication with my gateway now? Try again. Still no. Why? Let's check on the switch. Do show VLAN brief. So Z0/0 and Z0/2, they are part of VLAN 10. Z0/1 and Z0/3 are part of VLAN 20. This is okay. And this is also okay. Clear? So now we have communication. What about communication from PC1 to PC2? Without routing, will I have communication? Because I have communication between two different networks. So am I going to have communication here? Why?
Directly connected.
Exactly. Both the networks 10.1.1.0 and 10.2.2.0 are directly connected to the router. Right? So that means for directly connected networks, router will already have the routes in the routing table. Correct? So if I try, how many packets will drop? How many packets will drop? How many packets will drop here? Why? So what? Earlier I pinged my gateway only. Now I'm pinging the second PC.
One will
How many packets will drop? Tell me something. You are saying one. What about other people? How many packets will drop? One. How many packets will drop here? One. Two packets. One. Three. One. Two. Two. Yes. How many packets? Say 1, 2, 3, 4, anything.
2, 1. Not sure. Why? I think. What do you think? Hmm? Louder, please. No packet will drop. Why? Already? I ping the gateway only, right? This time I'm pinging a different network. This time I'm pinging a different network. So, not sure. Online people, how many packets will drop here?
Sir, 4 packets.
Packets. Okay. Answer is 4. 0. Answer is 0. Why? PC generates the app for gateway. So answer is no. Pay attention here. I only pinged from PC1 to gateway. Did I ping from PC2 to gateway? No, right? I did not. Let's try. Still 0. Because PC holds the packet. Router drops the packet. PC does not drop the packet. Understood? So this is how the communication will take place. I think I have discussed this part that PC does not drop the packet. PC holds it and router drops it. Okay, so that's why no packet drop here. Clear? Okay. And from here to here, let's try to ping 10, 1, 1, 10. Right? I have the communication. Understood, router with separate interfaces. Nothing special configuration, just these ports has to be in the correct VLAN. That's it. Clear? Okay. Now let me wipe switch and also the router. Okay, second scenario. Router on a stick. Now we know that we cannot use multiple interfaces. Router come up with limited interfaces, right? So I'll take a router again. But this time, instead of using multiple interfaces, I'll use a single interface only. Okay. And these guys, they are still in the different VLANs. VLAN 10. VLAN 20. And this is VLAN 10. On this side, VLAN 20. IP addresses are also same. 10.1.1.10. 10.2.2. Interface, let's say gig 0/0. This is Z0 by 1. Okay, and this interface here, this is Z0 by 2. Okay. This is again our gateway. And this interface is gig 0/0. Now the thing is, for 2 different networks, how many gateways I need? 2. So that means on this interface, I need to set 2 IP addresses, which is 10.1.1.1 One IP address I need to set is 10.1.1.1, and second IP address I need to set is 10.2.2.1. But can I configure two IP addresses on one interface of a router?
Yes, virtually you have to configure it.
Virtually.
On the interface, you cannot give.
You are in routing, I guess. Now don't speak in switching. Okay. So those who are attending the routing batch, they will remain silent. Okay. Question is, how many IP addresses you can configure on one interface of a router? Those who are attending routing will not answer it. Remaining guys tell me. How many IP addresses can be configured on one interface of a router without creating sub interfaces? Yes, tell me. How many? Sure. Yeah, without sub interface. How many IP addresses? One. Okay. Anybody else who wants to answer? No. Wait for it. I'll show you how many you can configure. What about PC? How many IP addresses you can configure on a PC? On one interface of a PC? On a computer, on one NIC, how many IP addresses you can configure?
Four.
4. Okay. What if I want to configure more than 4? See here. This is my one NIC. I have one adapter. 1, 2, 3, 4, 5, 6. And I can even configure more. Right? What about router? So on one interface of PC or one NIC of PC, you can configure multiple IP addresses. Right? Now take a look here. If I check show IP interface brief, let's say this is the interface. Right now IP address is unassigned. So if I go to this interface and if I say IP address, let's say 10.1.1.255.255.255.0, this IP address will get configured. Correct? Configured. Okay, what if I use this command again and if I say 2.2.1? It will overwrite. The IP address is overridden. Okay. What if I again go and say 10.1.1.1? What will happen? Overwrite.
Yes.
So that means I can usually configure one IP address. Okay. What if I use this command and if I use the word secondary?
Then I can configure. Check. How many IP addresses? One only. How many IP addresses? Two. How many IP addresses? Right? That means how many IP addresses I can configure? Two or more? No idea. Okay. This is the command. Other than secondary, I don't have any other word. I cannot say tertiary or something like that. What if I'll go something like 3.3.1? Now what should happen?
It will overwrite the secondary IP.
Okay. What is happening? Right? If I say 4.4.1, now what will happen? So don't say it will overwrite. Understood? So you can configure multiple addresses. You can configure multiple addresses on one interface of a router. But you can configure one primary and multiple secondary addresses. And these are addresses, these are used for communicating with different networks. Clear? Okay. Hmm? Yes. Now, let's set the configuration back to default. Okay, so you can see I have multiple configurations right now. Right? Now, if I want to remove this configuration, what I can do? How many times I have to use no command if I want to remove these addresses? If I need to remove all these addresses, how many times I have to use the no command? 4. Technically, 4. But eventually what I want to do is I want to reset this interface. So rather than giving 4 times no command, what I can say? I can say default interface gig 0/0. So this will set the interface to its default configuration. And by default, the interface doesn't have a configuration. Understood? Note down this command. Okay. Now, so right now I'm using only one interface and I need to configure these two IP addresses. So what I'm going to do here, I'm going to use the concept of sub interfaces. I'm going to use the concept of sub interfaces. Okay.
Sir, how many IPs configure in router and switch? Sorry, router and PC?
How many?
IP.
Multiple. Answer will be multiple. Yeah. Okay, because multiple secondary addresses you can configure.
Okay.
Yeah. Now, sub interfaces, right? So here we have to use the concept of sub interface. Sub interface means you divide one interface into multiple logical interfaces.
Okay. So if you want to divide an interface into sub interface, first thing is whatever the physical interface is there, let's say in our case, it is Z0 by 0. So make sure the interface is up. Your physical interface has to be up. Second thing, what you have to do is you will just go and create the sub interface. So how do you create a sub interface? You will say interface, then whatever the interface number, dot, and after dot, you can use any random number. There's a large sequence. Okay. So let's say as of now, we have VLAN 10 and 20. So I'll use 10. Now you use sub interface only in case of inter VLAN routing. Whenever you have to deal with the VLAN traffic. So you must tell your router about the encapsulation method also. So you will say encapsulation, let's say .1q, and then you will give your VLAN ID. That for which VLAN you are creating this traffic. So this traffic will be dealing with the traffic of VLAN 10. Then after you can give the IP address. So you will say IP address and whatever the IP you want to assign. Okay. Then after similar configuration for the second sub interface also. So here you will say this is 20. This is going to deal with the traffic of VLAN 20 and this IP is going to be 2.2.1. On the sub interface, you don't need to give a no shutdown command. Why? Your physical interface is already up. Clear? So this will be configuration on your router side. And if you talk about switch side configuration, these two interfaces you will add in the VLAN 10 and 20, and this interface you will make it as a trunk, so that it will carry the traffic of all the VLANs. Okay. So here, this interface you will make it as a trunk. And here you will divide this interface into Z0 by 0.10 and Z0 by 0.20. Okay. This will be 10.1.1. This will be 10.2.2. Clear? And on the switch side, what you will do is okay, you will say interface gig 0/0, switch port access VLAN 10, interface gig 0/1, switch port access VLAN 20, and 0 by 2, switch port mode 1. This is all the configuration. And this is what router's configuration. Okay, clear? Note it. Then the method number 3 is about layer 3 switch. So let's quickly go and configure this thing. So I'll say interface gig 0/0, no shutdown. Okay, then I'll say interface Z0 by 0 dot, and you can see there's a interface Z0 by 0 dot. You can see there's a large sequence. So I'm using number 10. Then I'll say encapsulation .1q for VLAN 10. Then I'll say IP address 10.2. 10.1.1.1, 255.255.255.0. Okay. Then dot 20, encapsulation 20, and this is 2.2.1. Okay. Do show IP interface V. So you can see on the sub interfaces, I have the IP and these interfaces are okay. Then on the switch, interface gig 0/0, switch code access VLAN 10, Z0/1, VLAN 20, and Z0/2, switch code mode. Okay, so encapsulation I have to give switch code trunk encapsulation .1Q, and then switch code mode trunk. And then I can have communication. First is timeout, second timeout, third timeout, still timeout. Okay. Show VLAN brief. So Z0/0 is correct VLAN, Z0/1 is in the correct VLAN, Z0/2 is trunk, that is okay. And here dot 10 is okay, dot 1. We have the communication. Okay, just take some time. This is clear. Method number 3 is about layer 3 switch. Layer 3.
Sir, fourth command in encapsulation dot one Q 10.
Hmm.
That is 10 is a sub interface, right?
10 is a VLAN ID.
VLAN idea.
Yeah.
Okay.
This is VLAN ID. This 10 is VLAN ID. Then we use layer 3 switch. Again, 2 nodes we have. This is, you can say, a multi-layer switch. This interface gig 0/0. This interface gig 0/1. C1, PC2. This side VLAN 10. On the other side VLAN 20. VLAN 20. VLAN 10. This guy has an IP address 10.1.1.1. This guy has an IP address 10.2.2.1. Okay. So here what you have to do, here you have to use the concept of SVI. Stands for switch virtual interface. Okay, so basically what you have to do, you have to create the interface for the VLAN only. You have to create the interface for VLAN only. Okay. So if we talk about the configuration of the switch, this will be what?
You will say enable. Okay, then you will say configuration terminal. Then interface gig0/0, switch port access VLAN 10, interface gig0/1, switch port access VLAN 20. Then you will create SVIs. Okay, so SVI is for interface VLAN 10. Like this, you create SVI, interface for the VLAN itself. And then on this interface, you can assign IP address, whatever the IP address, 10.1.1.1. Okay, these are 10.1.1, 10 and 20. 10.1.1, 10, 10.2.2, 10, right? 255, 255, 2550. No shutdown. And then same command for the second interface also. Okay. Once you create the SPIs, last thing you do is enable IP routing on the switch. Because even your multi-layer switch by default work as a layer 2 only. Even your multi,
Sir,
yes.
sir, sixth line interface VLAN 20, right?
Yeah, interface VLAN 20. Correct. The IP will be also 2.2.1. Okay. This will be 20. This will be 20 and okay.
Above also 20, right? Which
Yes, yes. And
will,
which one? Yeah, here also.
okay.
I just copy pasted. And these IPs also. These are .10. Okay. So this is the configuration. This is 10 and 10 and 10. Clear? Let's go and see this practical. So wipe the switch and delete. Okay, all these IPs will be in the SVIs. And this is a layer 3 switch. Okay. Now, power on the switch. So right now you'll see that I don't have communication. Okay. Once I'll configure interval and routing, I'll have communication.
configuration terminal. So what I'll do, I'll say interface x0/0, switch port access VLAN 10. Okay, Z0 by 0 in VLAN 10 and Z0 by 1 in VLAN 20. Interface Z0 by 1, switch port access VLAN 20. Then we will create the SVIs. Even now you will see I don't have the communication because gateway is not present. Okay. So what I'll do is I'll just go and create SVIs. So I'll say interface VLAN 10 IP address 10.1.1.1 255.255.255.0. Okay. This is the command I used. Okay. Then no shutdown. Interface VLAN 20. Then IP address will be 10.2.2.1. And I'll say no shut. To show IP interface brief. So you can see VLAN 10 IP address 10.1.1, VLAN 20 IP address 10.2.2.1. Then we will enable IP routing. And we can see the communication. It will take some time and we will see we have the communication. Yeah. This is your inter VLAN router. Any doubts? Online people?
No, sir.
So then tomorrow, I mean next working day, which is Monday, we will start with the STT, spanning tree protocol. Okay, guys, then this is it for the day. I'll see you guys on Monday. Have a great weekend.